Yeah, I think that's a really good question. And when I do talks at schools or talk to people at the open days, this is one of the things they really want to understand. I'd say, the first thing I really want to emphasize is you're not doing less physics by taking this option. So by the time you graduate after 3 or 4 years, in Cambridge, if physics is your interest, you will be stretched and challenged in physics, and you will be taught right up to sort of the forefront of research. So you will be getting lots of rigor and lots of content in physics. The difference, I suppose, is in the first year, especially where you're doing these three topics. And I think there are a number of reasons we teach this way. The first is it gives you a chance to try out different areas of science before you specialize. So many students, thinking about applying to university, 16, 17, you're thinking, actually, I really like physics. I think that's what I want to study. But the way it's taught at A level may not be the way it's taught at first year university. So you come into university and you think, actually, maybe physics isn't really what I want to specialize in. But that's okay because the course is very flexible. So you can try an area before you specialize. The second reason, I think, is because it allows you to explore topics you won't have seen at A level. So we talked about materials and earth sciences. But again, you can do a biological option, say the biomedical sciences option, and that could really spark some interest in you that you hadn't thought about if you didn't do an A level in biology. But perhaps the most important thing, the third reason I think we really want to keep this in mind is it builds up interdisciplinary thinking. And this is really the way, a lot of research is headed. This is where the Nobel Prizes of the future are, bringing together ideas from, physics and biology or, materials and chemistry, combining them. And, we think giving students a good grounding in their first year promotes this sort of interdisciplinary thinking, which is really important in science.
Hello everyone, welcome to Cambridge from the Inside. We're here with a returning guest. Would you like to introduce yourself?
Sure, I'm Michael Sutherland. I'm the senior tutor of this college, but I'm also a director of studies in natural sciences and a physicist.
Nice. So as Michael was saying, we're going to be talking about studying physics at Cambridge and talking more about the natural sciences course and the physical natural sciences route into natural sciences. So to start off with, Michael, if I'm a prospective student and I want to study physics at Cambridge, how do I go about doing that?
Well, I think the first thing you need to do is choose your A levels correctly. So we'll be looking for students who have mathematics plus 2 other science A levels, and this could be physics, chemistry, or biology, or indeed some other topics. And you can talk to your prospective college about what other A levels are acceptable. So you need to have the right set of A levels, but then you also need to develop your skills so that you can excel in some of the selection process that we use to bring students on board. For instance, the admissions assessments and our interviews.
Nice. And just for anyone who doesn't know, when you're choosing a degree course to study, can you choose to study physics at Cambridge? Can you explain a bit about that?
Yeah, so Cambridge offers a different course structure, I think, than many other universities. So many universities in the UK will offer a single science option. So you'll apply to take, say, physics or chemistry or materials. Cambridge has what's called a natural sciences course, and that allows students to try a number of science subjects before they specialize. So you do a range of science topics in your first year, and then you choose the science that you really want to dig deep into, like physics or chemistry.
Nice. And so in the natural sciences course, when you look at the course page, there's like a section on biological natural sciences and a section on physical natural sciences. Can you explain a bit about those two differences, and are they 2 different courses?
Yeah, it's actually all just the same course. So it's all natural sciences, but those 2 streams are designed really to help us in the application process. So if you opt for, say, the biological natural science course, you would be taking mainly the biology options, and that would mean your assessment, your interviews would be tailored towards your interest in biology. But once you're here, on the ground, you can mix and match the courses as you like, and you can even switch from sort of one stream into another. The course is very, very flexible in that way.
Nice. And with regards to students making course choices once they're studying natural sciences, do they get a lot of support from their tutors or directors of studies?
Yeah, I mean, one of the great things about the Cambridge system is that when people come and join our university, you're given through your college both a tutor, who's somebody who can look after your pastoral needs, but also a director of studies. And that's an academic who would be doing research or teaching in natural sciences. And it's the director of studies role really to help you, find your way, navigate your way through the natural sciences course. So helping advise you on what topics to choose, what papers to study, as well as great resources to enhance your study.
Nice. So with regards to the application side, I know that entry requirements can subtly differ between colleges, but what tends to be the main things that a student would need, or then the general entry requirements for physical and natural sciences?
Yeah, I think it's a requirement that anybody applying for natural sciences has at least A-level maths or the equivalent. And if anybody's doing the IB, that would be the analysis and approaches higher level. So that's the sort of core thing. And in addition to that, it would be 2 other sciences. And there's a range of other science options you could take. You could do physics, chemistry, you could do further maths, you could do one biology, say. And some colleges will look at other sciences like computer science and consider that as part of the 3 required 3 science and maths A-levels.
Nice. And for the physical and natural sciences application routes, what set of A-levels would tend to be would make a strong application or help someone, would equip someone to thrive in the course?
Yeah, I think very common combination for us would be mathematics with, say, physics and chemistry, or mathematics, further maths and physics. Those are probably the most common combination of A-levels. Whether you take A-level chemistry or not does have some bearing on what course choices you can make in your first year of university. So if you want to do the chemistry option in the first year of natural sciences, you're required to have chemistry at least to AS level.
Okay. And are there any advantages to having 4 A-levels compared to 3 A-levels?
I think if your school offers further maths and you find mathematics interesting and stimulating, it's worth taking that as a 4th A-level if you can balance your time. The natural sciences physical stream here is pretty heavy in mathematics, and we do require a good deal of fluency. So people find further maths to be very helpful. But if your school doesn't offer it, that's absolutely fine. So it's okay to come in on, say, chemistry, physics, and single maths. We'll give you a worksheet to do over the summer to plug any gaps you might have in your mathematical knowledge. And you can hit the ground running in October just with the single maths. But I would say if that further maths option is available in your school and you think you can manage your time well to do the 4 A-levels, I would recommend that.
Nice. Yeah, I remember when I was choosing my A-levels, I did maths, further maths, biology and chemistry. And I liked the idea of doing further maths because it opened up different pathways. If I hadn't, if I wasn't sure about studying science, I might have wanted to study maths. I hadn't closed either doors. I guess that's an advantage of doing further maths or doing a 4th A-level. I guess you just have more options in university. Yeah,
and within further maths, there are some really good modules, like the mechanics modules, that prepare you very well for first year physics at Cambridge or any other university.
Nice. Am I right in thinking that someone can apply for natural sciences if they're doing physics, maths, and further maths?
Yeah, that's absolutely fine. As I mentioned, you wouldn't be able to take the chemistry option in your first year of study, but math, further maths, physics is perfectly acceptable.
Nice. Okay. And for natural sciences, whether that's the biological natural sciences application route or the physical application route, is there an admissions test?
Yeah, everybody has to write an emissions assessment. We call it the ESAT, and that's sat by both engineers and natural scientists. Whether you're going through the biological stream or the physical stream, everybody sits this test. But it's not all of the same questions. So, we're not asking those interested in, say, the physical sciences route to do biology questions. In that ESAT test, and you can find out more online, you're required to do a section of mathematics, and then you're given some flexibility of whether you want to answer questions of biology, chemistry, or physics, or indeed more math questions.
Nice. And how are the questions on this admissions test very similar to like A-level exam scripts, or how do they differ?
Now, much of the content is actually drawn from the GCSE syllabus, so they're fairly short multiple choice questions. So if you look at some of the examples that you can find online, you're spending something around 90 seconds on one of these questions. So it's the content is not particularly at a high level, but the time pressures are very high. So you've got to answer quite a few of these questions and do calculations within a very short period of time. And that's where students find that the challenge lies.
So what would you, for someone who's wanting to apply for NatSci, natural sciences, what's the best way for them to prepare for these admissions tests?
Yeah, so there's a lot of really good resource material online, and I would strongly recommend anybody looking to apply to natural sciences have a look at the past papers that are online. They go back a couple of years. Before it was called the ESAT, there was a similar test called the NSAA. That's a Natural Sciences Admissions Assessment. The format has changed slightly, but the style of the questions is broadly similar. So you can prepare also by looking at some of that older content, while keeping in mind the actual ESAT that you sit will be different. But really strongly advise trying those past papers under time conditions. So it will tell you how long you have for each section. Give it a go with your stopwatch and practice, getting quick. It's a bit like training for, a race. Yeah. You got to push yourself, time yourself, and you'll find, you'll improve as you go through.
Yeah, in that the more practice you do, you see that your time is getting better. You're doing them at a faster pace.
Yeah, and you'll find little shortcuts. Just your speed of calculations will improve. But all of this, I think takes a bit of foresight. So you can't sort of say, well, I've got this ESAT in 3 days, I'm going to start studying now. I think I'd recommend probably a good time to start preparing for these things is if you're applying in year 13 in the summer between year 12 and year 13, dust off your old textbooks, get these tests out and practice them under time conditions.
Nice. That's really good advice. So with regards to the course, the natural sciences course and the course content, in the first year, there are several physics related modules, and one of them physics itself, but also courses like material sciences and earth sciences, that courses that students might not have heard of. Can you briefly explain what material sciences and earth sciences are?
Yeah, so these are really interesting topics that probably most people wouldn't have been exposed to in their schooling. So there's not, an A-level or IB higher level in material science or earth sciences. So many students will be seeing this content for the first time. So I'll tell you a little bit about earth sciences. So earth sciences is really the study of our earth and all of the dynamic systems within it. So you learn about things like modeling climate, how to understand sort of energy transfer to the earth as a system. You look at geological processes, formation of minerals, how weather and water shape and form the earth. And one of the highlights of that trip is always, highlights of that course rather, is a trip to the Isle of Arran in Scotland, where you can see some of these geological processes you've been studying firsthand. And students really, really love that hands-on nature of earth sciences. In the material science course, this is really just the study of the materials that we use and we find interesting as a technological society. So things like understanding what the atomic structure of materials are, so crystals, and what that means, understanding why things have certain mechanical properties, so whether they're brittle or ductile, they can be pulled or bent, understanding that from a microscopic perspective, learning about some of the techniques that we use to identify and characterize material, like X-ray crystallography, and studying materials that are used for devices, so things like semiconductors that we use in all of our electronics, a number of other topics as well.
Nice. From what you're saying, material sciences sounds like it had quite a bit of overlap with some parts of chemistry. Do you need chemistry A level in order to do material sciences?
Yeah, so certainly I think that's a good observation. So material science does bring together ideas from chemistry, from physics, from mathematics, but it's not required for you to have an A level in chemistry to be able to take the materials course. Any of the chemistry that you would need in that course would be reviewed for you.
Nice. So am I right in thinking if someone is applying for natural sciences, they have physics and maths and maybe a couple of other A levels, and they're interested in chemistry. They might not be able to take the chemistry course, but they can do inorganic and physical chemistry in the material science part.
Yeah, there'll be elements of chemistry in the materials, but very much with an application, a focus on materials. Yeah.
Nice. And another thing that I noticed was in the second year of the natural sciences course, there's two physics options, physics A and physics B, and wondering if you could explain the difference between the two.
Yeah, so the structure of the natural sciences course, I think is really great because in the first year you have quite a bit of flexibility. And as we talked about, you're choosing different sciences, exploring what interests you. And then when you come to your second year, you're starting to specialize. And so those people who are interested in physics would probably take the two physics options in the second year, so physics A and physics B. So the aim of the second year physics courses is really to provide you with a sort of rigorous theoretical understanding of the basics of physics that you'll use to explore more advanced topics in your later years. So the Physics A course is designed around studying a number of subjects, one of them being waves and the properties of waves, which you would use in later years for say, quantum mechanics. So you do some waves and oscillations, you do some introductory quantum theory, and then you do a little bit of what we call condensed matter physics, so introduction of to physics of material. So a bit like material science, but looked at through the lens of a physicist. So that's the Physics A course. Physics B topics tend to be a little bit more mathematically advanced. So you do some electromagnetism. There you're using vector calculus to explore the properties of electromagnetic fields. And that has many, many uses in further advanced topics. You're also being exposed to dynamics, so looking at how to apply more sophisticated mathematical techniques to study dynamics problems. And then you also do an introduction to thermodynamics as well. So that's pretty similar ideas in Physics A and Physics B, giving you that sort of foundation of theoretical techniques and knowledge in physics, but the topics are just slightly different between the two courses.
Nice. And you're saying that you specialize a bit more in second year. Could you give us a overview of like how many modules you choose in each year and how you specialize more and more until the end of the course?
Yeah. So in first year natural sciences, you do a mathematics course. Everybody has to do a mathematics course. And then you choose 3 science options. So many people who are interested in the physical side would do, say, physics, chemistry, if you have AS level chemistry, and maybe material science, or perhaps earth sciences, or indeed one of the biological options, because you don't have to have a biology A level to do one of the biological options. So you sort of try these 3 different sciences, and then as we talked about, you start to specialize in your second year. And you choose 3 modules or papers, we call them, out of 20 different options. So if you're really set on physics, you do the Physics A and Physics B that we talked about, plus the second year course in mathematics for natural sciences. If you wanted to do chemistry, you do the Chemistry A, Chemistry B course. But there's also options, material science you can do earth sciences. There's a whole range of different topics that you can start to, get a bit deeper into.
And in the and how many modules do you choose in the third year?
Yeah, so in the third year, then you specialize into one particular area. So it could be physics, it could be chemistry, it could be earth sciences. But within that, there'll be some flexibility of what lectures you go to, what topics you explore. So in the third year of physics, for instance, you get to choose a number of options. So you might be more interested in the sort of the biological physics side of things, or you might be interested more in nuclear and particle physics. You can sort of find your way through the physics courses within the physics, within the physics topics in third year.
Nice. So, say in the second year, someone was to choose one of the physics papers and two other papers, could they then do physics in the third year, or do you need both physics?
Yeah, so most of our students would have Physics A and Physics B and the mathematics course to go into the part two of the physics. That's what we call our third year, because you need that sort of, that foundational knowledge to be able to deal with the more advanced topics in the third year.
Okay. And as you said right at the beginning, most universities don't offer natural sciences. They would offer a physics course. What would you say is the benefit of what are the benefits of studying natural sciences opposed to studying a straight physics course?
Yeah, I think that's a really good question. And when I do talks at schools or talk to people at the open days, this is one of the things they really want to understand. I'd say, the first thing I really want to emphasize is you're not doing less physics by taking this option. So by the time you graduate after 3 or 4 years, in Cambridge, if physics is your interest, you will be stretched and challenged in physics, and you will be taught right up to sort of the forefront of research. So you will be getting lots of rigor and lots of content in physics. The difference, I suppose, is in the first year, especially where you're doing these 3 topics. And I think there are a number of reasons we teach this way. The first is it gives you a chance to try out different areas of science before you specialize. So many students, thinking about applying to university, 16, 17, you're thinking, actually, I really like physics. I think that's what I want to study. But the way it's taught at A level may not be the way it's taught at first year university. So you come into university and you think, actually, maybe physics isn't really what I want to specialize in. But that's okay, because the course is very flexible. So you can try an area before you specialize. The second reason, I think, is because it allows you to explore topics you won't have seen at A level. So we talked about materials and earth sciences. But again, you can do a biological option, say the biomedical sciences option, and that could really spark some interest in you that you hadn't thought about if you didn't do an A level in biology. But perhaps the most important thing, the third reason I think we really want to keep this in mind is it builds up interdisciplinary thinking, and this is really the way a lot of research is headed. This is where the Nobel Prizes of the future are. Bringing together ideas from physics and biology, or materials and chemistry, combining them, and we think giving students a good grounding in their first year promotes this sort of interdisciplinary thinking, which is really important in science.
Nice. And for someone who's listening, like a upcoming physics student, listening to this and think, well, why would I want to choose a biology module if I'm interested in physics? But at research, there is a lot of overlap between the two, I imagine.
Yeah, I think so. I mean, if you go out to the Cavendish lab where physics is based, you will find people doing research right at that forefront of biology and physics. So looking at advanced techniques for imaging cancer, for instance, that's an area people are interested in. Trying to understand the way cells and cellular processes work from a sort of physics point of view, bioengineering material, using DNA to build structures. All of these things require the sort of tools and techniques of a physicist, but some foundational knowledge in biology. We think that's a really fertile area for research.
Nice. So with regards to all of them like modules that are on offer for students, have you seen many students who start off thinking that they want to do straight physics all the way, but then end up going on to do modules that they did not expect to do?
Yeah, absolutely. And I think, students, as you say, come in, with a particular focus in mind. And once they experience other areas of science, sometimes that sparks a bit of interest. So I have had students coming in, thinking they want to do physics, take a biology course in their first year, one of the biology options, and head more down towards a biological physics or a mathematical biology route. That's not uncommon. The other thing I suppose to mention, and I think is a really great strength of our system, is we try to give students lots of opportunity to do their own research. So in the third year of the course, you can opt to do a research project in physics, but many of those will be in topics that are interdisciplinary, as we talked about. And sometimes students will use that as a basis to go off and do a PhD in a slightly different topic. But that, again, in natural sciences, that flexibility is really at the heart of what we do.
Nice. And quite a different question now. A lot of prospective students, when they're thinking about whether they want to study physics, they'll also be thinking about whether they want to study engineering, and they'll be comparing the two courses. Can you explain like the main differences between like physics and engineering?
Yeah, I mean, there's a lot of similarities actually. So the course content of the first year physics course will touch on many of the same things that the engineers do, mechanics, this kind of thing. But I suppose the engineers are looking at everything through the lens of applications. So we're studying mechanics, and we want to understand that so that we can build a stronger bridge, for instance. Yeah. Whereas physicists tend to focus more on the sort of the mathematics of it, the sort of theoretical implications of the ideas, without necessarily thinking about the applications. Although, as a physicist, we do think about that as well. It's probably worth noting at the sort of research level, there are often collaborations between engineers and physicists. So our two departments do talk to each other quite a bit. But from the student point of view, I would say if you are interested more in the applications of building things, technology, probably worth thinking carefully about engineering. If you're more interested in just the sort of fundamentals, understanding from a mathematical point of view how the world works, how the universe works, probably physics is more for you.
Nice, interesting. And similarly, I imagine these exact same students might be thinking about deciding between studying physics and studying maths. And I was wondering if you had any advice of how a student should choose between those two courses.
Yeah, that's a difficult one. I think there are opportunities within the Cambridge system to study, if you're going through natural sciences, to study some of the topics in physics from a very rigorous mathematical point of view. So particularly if you advance to the fourth year of the degree, so we call that part 3, some of the topics that that you can study will be offered jointly with mathematics. So things like quantum field theory, for instance, and topics in general relativity. So you can go through from the sort of natural sciences route to something that is very mathematical and theoretical. I suppose the bonus is if you go through the natural sciences route, you also get a pretty good understanding of experimental techniques. So you need to do some lab work in your first and second year. And that, I think, gives us a good sense of how we measure things and how measurements can sometimes tell us things that are incorrect and to understand why that's the case. If you just go down the maths route, you don't have any of these sort of practical courses. And then I would say there are areas of the mathematics course, particularly in pure maths, that are very, very abstract and fascinating stuff, interesting in its own right, but probably slightly tangential to the more sort of practical applications of mathematics. So if you really like thinking about quite theoretical, abstract ideas in mathematics, it's probably the best route for you. But if you're interested more in the application of maths to physical problems, I'd argue natural sciences is a great way forward.
Nice. Wow, that's really cool. Makes me wish that I did physics A level, but alas. And wanted to move on to finally about what kind of research interests that you're doing and what you're interested in.
Yeah, so I have research interests in an area of physics called condensed matter physics. So this is the study of really solids. And in particular, I'm interested in systems which exhibit really unusual quantum effects, particularly at extreme conditions like low temperatures. So I've done research on a class of materials called superconductors. And these are materials where when you cool them beneath a certain temperature, electrons inside of them will conduct electricity with no resistance. And this has lots of really interesting applications from a technological point of view, but from a sort of a pure physics point of view, how the electrons do that is not fully understood in every material.
Nice. So that kind of field of work and theory, is that related to the quantum mechanics side of things or the thermodynamics side of things?
Yeah, I mean, the theory of superconductivity actually brings in ideas from both of those areas, but it's primarily sort of a quantum phenomenon. It's a really unusual thing because electrons, they have the same charge and you think of them as wanting to repel. But in superconductors, they're actually sort of bound together into a composite object called a Cooper pair. And this gives it the ability to sort of transport electricity through this material with no resistance. And that would mean, conducting electricity over vast distances without losing any energy, which is really interesting from a technological point of view. The difficulty is these things all sort of work at minus 200 degrees Celsius. So we haven't quite cracked the problem of getting these things to work at room temperature, although there's a lot of promising developments in this area.
And am I right in thinking there's a lot of application potentials for applying that in real world problems?
Yeah, so energy transmission is one area. Using superconductors as the basis for quantum computing. So the little qubits inside of a quantum computer, that's one area of application. But superconductors actually already have found huge uses in generating big magnetic fields. So because you can pass electrical current without any loss, if you make a solenoid, which is sort of a cylinder, coil of wire, pass a big current through there, you can generate huge magnetic fields. And if you've ever had an MRI or know somebody who's had an MRI, they're sitting inside a giant superconductor there. So there's already really profound applications for these materials.
Nice, amazing. Well, thanks, Michael, for such an interesting podcast on studying physics at Cambridge. I think we've provided a very comprehensive and clear view of how the course works. Do feel free to ask any questions that you have with regards to the course in the comments. We're hoping to do more podcasts on the remaining courses in Cambridge that we haven't done. So stay tuned for that, and we'll see you guys next time.
Thank you.
Nice. Oh, how was that?
Great. Yep. Sounds good.
Nice. Yeah, it was really good.